Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 9, Section 10, titled Rotations. By the end of this video, you will have reviewed recent lessons regarding rotations, graphing rotations, finding a rotation image, identifying rotational symmetry, and a real-world problem regarding rotational symmetry. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's get into it. Okay, let's start with some definitions. A rotation. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. The angle measure of the rotation is the angle of rotation. The center of rotation. The center of rotation is the fixed point around which a rotation occurs. It's like holding it with your finger and spinning it, right? So it'll go around that point. Angle of rotation. The angle of rotation is the angle measure of which the figure is rotated. So if you start rotating at about point A, for instance, and you pull it 90 degrees, that's an angle of rotation of 90 degrees. Objective 1, graphing rotations. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. The angle measure of the rotation is the angle of rotation. In the diagram, triangle QPR is rotated 90 degrees about the center of rotation, point P. Notice that M, that's the measure of angle QP. Oh, I think there's a mistake there. QPR is 90 degrees. And the measure of angle RPR prime, oh, I see, it was a Q prime. Sorry for disrupting that line of thought there. The measure of angle RPR prime is equals 90 degrees. A figure and its rotation image are congruent. So in the diagram, the direction of rotation is counterclockwise. All rotation in these reviews will be counterclockwise. And you can graph a rotation on a coordinate plane. But as you see it here, we'll go up and look. We started off with this figure right here, and it's being rotated around this point P. And they've taken Q and R and they shifted each line. So line PQ goes 90 degrees. That's the full. You see a nice little right angle there. And PR is also rotated 90 degrees. So PR is up maybe 30 degrees above zero at its start. And when it gets done, it's like 120 degrees. It's 0, 90, 100, 120. It's further along. But the center of rotation is P, and the angle of rotation in each case is still 90 degrees. Everything rotates together. Okay, example 1, finding the rotational image. Find the vertices of the image of triangle ABC after a rotation of 180 degrees, about the origin. Okay, so that means we're going to be rotating about this point. Where'd my pencil go? There it is. Rotating around this point right here, the origin. It's the origin right here. It's got a little O there for origin. Draw triangle ABC. Okay, you've got triangle ABC drawn. Place a piece of tracing paper over it. So they're kind of talking about what I was saying earlier. You take your finger and spin a piece of paper around your finger. It's that tracing paper they're going to spin around your point they're talking about here. Place the tracing paper over the graph. Trace the vertices of the triangle and the x-axis and the y-axis, and then place your pencil at the origin to rotate the paper. So you're going to go 180 degrees. So if you have a line for x and your line for y, when you rotate it around, your positive y will be up. 180 degrees later, your positive y will be pointing down. That way you know you've gone 180 degrees. And it lines up. Okay, so then place your pencil at the origin to rotate the paper. Like I said, you could put your finger there, right? So now if you put the pencil at the origin and use a point, you can freely move that paper around. Next, step 2, rotate the paper 180 degrees. Make sure the axes line up. Your X and Y, they've got to be exactly the same, only pointing in the opposite directions. Okay. Mark the position of each vertex by pressing through the paper. Connect the vertices of the rotated triangle. In other words, make the new triangle. The vertices of the image are A prime minus 1 minus 1, B prime minus 2 minus 3, and I should be saying C prime negative 3 and negative 2. Sorry for saying minus. I should have said negative. Okay. Okay, example 1, check your understanding. Directions, copy the graph of triangle ABC. I stuck the picture of it over on the right-hand side there. From example 1. Draw its image after a rotation of 90 degrees about the origin. Name the coordinates of the vertices of the image. Well, this is your job to go off and do it on your own. Get your piece of tracing paper and the like. I can't do that here, so we'll have to figure out a different way of doing it than with the tracing paper. So when you get back, we'll look at it. Okay, now that you're back, and you've had your time to draw the triangle and the like, I'm going to go ahead and try it myself, okay? And I'm going to approach it a little differently. So I'm going to start off by going angle A, vertex A is right here at 1, 1. So I'm going to draw it right here. A is 1, 1, 1, comma, 1. Okay. C is over at 3, comma, 2. Right here. 3, comma, 2. That's the X and Y position. And B is 2, comma, 3. B is 2, comma, 3. Okay? So we're going to move this triangle, which is this guy right here. If I can get it. A line down here, a line over here, and a line here. Okay, so there's the triangle. And I'll do an ABC also on it here. A, C, and B. Okay? And what we're going to do is get A prime, B prime, and C prime after you rotate it. Well, I don't have the little paper to do it, but I'm assuming that when you did it, you put the tracing paper on here, you pinned it right here at 0, and you put the Y coordinates on your sheet of paper or marked them somehow so that when you spun it around 90 degrees, I guess the graph would look so that Y plus Y would be pointing this way in the negative X direction, and the negative X would be now in the negative Y direction, and the negative Y would now be in the positive X direction. So you get the picture. You'd 90 degree shift. And it would take this triangle and it would rotate it around with it. Well, how does it rotate it? Well, if you did it correctly, I think what you're going to find is that when you moved 90 degrees, that's like if I drew a line through here, through this center right here, this is 90 degrees, right through here, right? If I do it from this point, right, through these hash marks here, that's the 90 degrees. So if you did that 90 degrees, C is going to be above the 90 degree on the one side, and B is below on the other side. Let's see if that works out. So I say that you do 90 degrees. Well, you're going to go from this point right here over to this point. And I'm going to also do something else. I'm going to say plus, 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 comma, plus. And I'm going to do minus, comma, plus. And I'm going to do minus, comma, minus. And I'm going to do plus, minus. Okay? So there's a plus, plus, minus, plus, minus, minus, plus, minus. So when we rotate 90 degrees, all these points right here are going to end up, they're going to end up somehow changing, aren't they? We'll show you how they're going to change. So as we move this guy from A from 1, 1, it's going to go 90 degrees over here to minus 1, 1. Minus 1, positive 1. It was positive 1, positive 1. Now it's minus 1, positive 1. minus 1, positive 1, positive, positive, minus positive. Okay, so that one right there is going to be minus positive. So I'm going to put it right in here. I'm going to do minus, this is A, minus 1, positive 1. That's A prime. Then we're going to, since we're going 9, this guy here is going to be below. Right now it's above, right? It's above C and A. But when we get over here on this other side, C is going to be above the B because it's going to go half over, so put C on top. Well, when you look at that, we're going to say B. B right now is plus 2 plus 3. Plus 2x plus 3y. Well, right now, we're going to rotate over here. The 3 and the 2 are going to switch. So the 3 is, it was plus 3 and y. Now it's going to be minus 3, minus on x, minus 3 plus 2. It's going to be right here. I think we're going to find out. I might be wrong. Minus 3 plus 2. It switched from plus 2 to plus 3. Now it's minus 3 to plus 2. It's, the numbers switched. Now for C, it's plus 3 plus 2. It's going to be minus 3. Oh, I'm down here. Well, excuse me. Minus, hold on. Let me get straight in there. We're doing C right now. This was B. I should have wrote B here. This is B. Now we're doing C. So C is x of 3, y of 2. We're going to be over on this side. It's going to be x of 2, y of 3. And it's going to go minus for the x and positive for the 3. So here's going to be C. I know this is a little hard to understand, but I don't have a way of rotating it. But if you would put your point now, you'd see that this would rotate over here, and your B should be here, and your C should be here. So C is going to be, or B is going to be minus 3 plus 2. I'm going to do it right here, minus 3 plus 2. Okay? And C is going to be minus 2 plus 3. Minus 2, I guess I should put comma, 3. Those would be your prime values. So hopefully that worked out for you. Don't try not to get confused over how I got the numbers. I don't have a way of rotating the paper, but yours should look like this. If it does, yours should look like this. Okay? With a 90-degree rotation. Let me know down below if it doesn't and I made a mistake here. It's possible I made a mistake. Okay. Objective 2, identifying rotational symmetry. A figure has rotational symmetry if you can rotate it 180 degrees or less so that its image matches the original figure. The angle or its measure through which the figure rotates is the angle of rotation. That's how far you're rotating in the angle of rotation. The wheel at the right has rotational symmetry. You can turn the wheel from its original position to 4 other positions, 5 positions in total. You just count them, 5 of them. And its picture will be the same as you see here. If you wrote this 1/5 of a circle around, you're going to find out that it looks exactly the same as you did when you started. Okay? The smallest such turn or move from A to A prime, the angle of rotation is 360 degrees divided by 5 or 72 or, okay? 5 would be the number of rotations. So that's the smallest such turn move from A to A. The angle can be, in your angle of rotation, is 360 divided by 5 positions, which is 72 degrees. So you could go 72, you can go 144. Okay, you can go around that way. Example 2, real-world problem solving. Botany. Judging from the appearances, state whether the flower has rotational symmetry. If so, what is the angle of the symmetry? The flower can match itself in how many places? 3 positions. We see that. 3 positions. The pattern repeats itself in 3 equal intervals. If you rotate this flower 120 degrees or 1/3 of 360, it's going to look like the same flower. generally, by appearances. The pattern repeats 3 equal intervals. 360 divided by 5 is 120 degrees. The figure has rotational symmetry. The angle of rotation is 120 degrees. Every 120 degrees, you'll see the same picture over and over and over again. Unless there are flaws or something, we're not counting the flaws in the leaves or something like that. The overall structure. Okay, example 2, we're going to check your understanding. Directions: judging the appearance, tell whether each figure has rotational symmetry, and if so, what is the angle of rotation? Okay, so take your time, look at it, come back with the answers, and we'll go through it. So, okay, now that you're back, A, does it have what did they want? Rotational symmetry, and if it does, what are the degrees? Well, there is no rotation. You cannot rotate this anywhere in 360 degrees and have the same pattern repeat. So the answer to this one is going to be no. Or where do we put it? Right here. Do I have a, yep, I've got color. No. Okay, let's go to B. How about B? Does this have angular rotational symmetry? Can you move it 90 degrees? And no. But you could move it 180 degrees and you'd see the same box, wouldn't you? The dot would be in the middle, the box would be upside down, but you'd be the same box. So this is yes. And it's 180 degrees is the symmetry. How about C over here? Does this have angular rotational symmetry? Well, if you rotate, well, how can you rotate this and get it to repeat itself? I think you can only rotate this if you flip it like this one all the way over to here one time. So there are two, I'm going to draw a line through here, and that would be the angle of symmetry. We can rotate this 180 degrees. If you rotate it anything less than 180 degrees, you won't get the same figure back. And so it does have rotational symmetry, and it is yes, and it again is 180 degrees.